Now that we've established that a dorsal root ganglion cell gives rise to an axon, sends one branch out to the skin or the muscles, tendons, or viscera, and the other branch to the central nervous system, we can look out in the skin. That's where we're going to look specifically. And we're going to look at skin along your fingertips. Let's just use them as the best example. So let's look out here in the skin. Let's look at this axon as it gets to its end in the skin. And what you'll notice is the axon can take one of several different morphologies. And that morphology is a lot wrapped up in non-neural cells. That is, cells that are not neurons, but come to have an intimate relationship with the tip of the axon. Now, let's deal with these guys first, because they're the star of the show for the second half of the lecture. They're called free nerve endings. They have no non-neural cells around them. I'm going to tell you that all of the somatosensory receptors that detect, that respond to stimuli that you wind up feeling as pain, well, they're going to end as free nerve endings. They're not the only guys that end in free nerve endings, but all of them will. A lot of other somatosensory dorsal root ganglion cells, DRGs, will send their axon out to the skin, particularly in the fingertips, and they're going to end in relationships with non-neural cells that can be corpuscles. And you'll notice 3 of these guys are called corpuscles: Meissner, Pacinian, Ruffini. Or they can end in relationship with a kind of cell called a Merkel cell. A Merkel cell is not a neuron, but it plays a fundamental role in transduction for cells that end on them. So Merkel cells. So you can, the capsules, or the corpuscles I should mention, they wrap the axon around. In this case, the Pacinian is the best studied. You won't notice because it's not high enough magnification, but the axon comes out to the periphery, and then it gets wrapped by a bunch of non-neural cells so that it looks like it's surrounded by a bunch of water balloons. Really, it looks like it's surrounded by an onion. Now that allows the axon to respond to a stimulus in an unusual way. So whenever you see a corpuscle, each of these guys, the Meissners and Pacinians in particular, we know that they are doing something to the stimulus that hits them. Now, we'll talk about that in just another slide or two. All right, so we're going to see that in another video. You should remember that the corpuscles are going to do something to the energy. If you apply a mechanical energy, like indent the skin to this guy, the corpuscle does something to that energy. So we're going to spend a lot of time talking about Meissner's corpuscles and Pacinians. I'm not going to spend any time talking about Ruffini's. We used to think we knew exactly what Ruffini's do. There's some doubt about that now. So I'm not going to talk about them. And we'll spend a lot of time talking about the somatosensory receptors that end on Merkel cells. The Merkel cell does play a fundamental role in the transduction of that stimulus. All 3 of these, Meissners, Pacinians, Merkels, are what we call mechanoreceptors. Mechanical stimuli. That is vibration of the skin or indentation of the skin. Something of mechanical energy, that is something physical, is doing something to the skin. And as a result of that physical indentation or movement parallel to the skin surface or vibration of the skin surface, the axon will respond accordingly. That you have different kinds of corpuscles and that you have these guys ending in Merkel cells tells you that these somatosensory receptors, the Meissners, the Pacinians, the Merkels, all transduce different kinds of mechanical energy. That allows you to feel the difference between simple indentation of the skin and movement of anything across the skin surface or vibration of the skin. You have different receptors for those 3 different qualities. All right? So, dorsal root ganglion cell ends in the skin. How it ends differs from one ganglion cell to the next. A lot of them end with no relationship to non-neural cells. We'll talk about them at some length later. Many of them end in relationship to a non-neural cell. Some end in corpuscles, some end in relationship to Merkel discs. All of these guys are mechanoreceptors. They detect the presence of a mechanical stimulus, but the mechanical stimulus detected by a Merkel cell, by these axons that attaches to a Merkel cell, that's different than the kind of mechanical energy that the Pacinian detects or that a Meissner's detects. So we're going to have to look now at what is the mechanical energy each of these guys detects.